Alright, this is check-in 12 for Dynamics. Um, yeah, I've been sick last week, so I haven't been able to put as much time as I want into this class. Um, as far as studying the, rigid body momentum, work and energy. Um, yeah, I've spent a good amount of time before I got sick, but that was the previous week. So this week I probably spent only 4 or 5 hours. Um, so yeah, not as much as I would like, um, but I definitely plan on, you know, spending a little bit more when I go through and finish the homework. Right now, about halfway through, so a little behind, but not too bad. Um, I've gone through a lot of resources. I went through pretty much all of the lecture videos, of your lecture videos on Canvas, also some other resources, this YouTube channel, as well as this YouTube channel had a lot of good information, as far as different types of problems, because, there's really, obviously there's near infinite variation when it comes to these kind of problems, so it's good to get like a good variety of them, um, just to get like a good idea of, um, how this could be used in real life, or when you may use stuff like this in industry, um, as well as is kind of how different problems can play out. You can find different patterns between, you have a question like this, which gears, that immediately clicks that there's going to be some kind of angular momentum, or angular velocity, um, that's ultimately going to, impact the momentum, because momentum requires a velocity, and angular velocity actually applies to that as well. So now not only can you have just like an object moving, now you also have to take into account the momentum from the rotation as well as the actual movement. So yeah, really just building off previous chapters here, more like just pushing two of them together, just making it bigger and better, because we already did the particle work and momentum, um, really the same concept, but now we just have to take more things into account, because the size of the actual object matters. uh, yeah, same thing with work. There's going to be a bunch of different ways these problems can play out. Like, for instance, this one has a spring. It could not be a spring. We could be dealing with, um, like the actual potential energy, how high something is, something falling, rotating as well, because rotation has to be taken into account, angular velocity with work as well, um, because when something moves in a circle, um, like the total amount of rotations, or if it's just a partial rotation, the arc length, that is going to be a distance, as far as that goes. So, and we know that work is force times distance. So yeah, obviously, like I mentioned before, just kind of going through and, um, just trying to solve all the different kinds of problems. Because I could probably go through and finish the homework right now. Um, and I probably should do that. I probably will do that tonight or tomorrow. But I don't know. I like to go through a bunch of different examples, and just to kind of see, what direction these concepts could potentially take us. So, yeah, thanks.